With that, we'll hand it over to Olivier and Michelle for the Assistance API.
Hello. Hi, everyone. I'm Olivier. I lead product on the OpenAI platform.
Hi, I'm Michelle, and I'm an engineering lead on the API. Today, I'm super excited to demo the new Assistance API. But first, Olivier is going to tell us a little more about it.
Let's do it. All right. It shouldn't be a surprise to anyone that there has been an explosion of AI assistants in the past year. ChatGPT, of course, unexpectedly took the world by storm a year ago. But the developer community has been building some amazing AI assistants as well. Some of my personal favorites are Spotify AI DJ, which personalizes my music listening experience, and the Ask Instacart feature, which helps me put together healthy meals for my 3-year-old toddler. When done right, those products are amazing for the product experience. They are fun, they are useful, and they truly personalize the user experience. But they are also extremely hard to build and get right. We've had hundreds of conversations with developers in the past few months, and the same pain points keep coming up over and over again. Developers have to manage limited context window. They have to manage prompts. They have to extend the capabilities of the model with their APIs and functions. They have to extend the knowledge of the model with retrieval. They have to compute, to store embeddings, to implement semantic search. The list goes on. And so that got us thinking. What are the right products? What are the right APIs? What are the right tools to help you all build such cool AI products? What are the right abstractions beyond our existing models and API? And so today, we are thrilled to introduce a new API, the Assistance API. The Assistance APIs enables you to build world-class assistants directly within your own applications. At its core, an assistant is an AI that you assign instructions to. And the assistant can call models and tools on behalf of users. Behind the scenes, the Assistance API is built with the same capabilities that you just saw for ChatGPT, such as code interpreter and retrieval. The API has 3 key primitives. Number 1 is the assistant. The assistant models instructions that you give to the model, to the assistant. And that's also where you're going to specify what models and what tools the assistant can access to perform its job. For instance, I could create an assistant whose task is to answer personal finance questions and can access code interpreter. So the first primitive is the Assistance API. The second primitive are threads. Threads represent a session between your users and the assistant. You can think of thread as a conversation. A conversation has a group of participants, and it can track the message history of the conversation. And very similar to Slack or Microsoft Teams, if you want to discuss a new topic or if you want to add new attendees, new guests to a thread, it's probably best to create a new thread. So the second primitive, threads. The last primitive is messages. Messages are simply posts between the users and the assistant. On top of these API primitives, we are super excited to release a few tools. The first tool is Code Interpreter. Most of you are already familiar with Code Interpreter in ChatGPT. Code Interpreter allows the model to write and run code in a sandboxed, safe environment. It can perform math, it can run code, it can even process files and generate charts on your behalf. It's pretty magical when you think of it. Code Interpreter can write and run code on your behalf. And so with the Assistance API, your applications will now be able to call directly Code Interpreter and get its outputs directly in the API. Pretty cool. The second tool is retrieval. Knowledge retrieval augments the assistant with knowledge from outside the models. The developer can upload their knowledge to the assistant, for instance, uploading some product information to the assistant. And users can as well upload, for instance, their own files, such as me uploading my personal master thesis to the assistant. And the assistant is going to intelligently retrieve the model depending on the user queries. It's a completely pre-built tool. There is no need for you to compute embeddings, to store them, to figure out semantic search. The Assistance API is going to automatically figure it out on your behalf. The last category of tools are tools that you host and execute yourself. We call those tools function calling. You define custom functions to the model, and the model is going to select the most relevant function based on the user query and provide you with the arguments to call the function. As a whole, starting today, function coding is getting smarter. In particular, it's much more likely to select the right arguments depending on the user query. And on top of that, there are two new features that we're going to go into much more details later on. But first on, let's do a cool demo of the Assistants API. On to you, Michelle.
Thanks, Olivier. Now let's get started building our very own assistant. So I'm building a geography tutor app to teach my users about world capitals. I can get started in just a few API calls. And since you all are developers, I'm going to start out in my terminal with some curl requests. You can see my terminal here. Awesome. So we're going to start with the very first curl request. So now we want to create this assistant to power my geography tutor app. You can see we're posting to the assistant's endpoint, and we're passing two key pieces of information. The first is the model. We're using the newest GPT-4 Turbo model, the latest heat that just dropped today. Next, we're passing the instructions to the model. You can see I'm asking the assistant to be helpful and concise and letting know that it's an expert. When I send that request, I get an assistant back, and I can store that assistant ID for use later. Before the Assistants API, if I wanted to use these instructions repeatedly, I would have to send them on every single API request to OpenAI. Now, with the new stateful API, I can create my assistant once, and the instructions are stored there forever. Now, let's move on to the next primitive that Olivier mentioned, which is threads. Threads are kind of like one session between your user and your application. So now I've got a user on my website, and they're starting to type out a geography question, so let's create a thread. You can see here, we're posting to the threads endpoint, and there's nothing in the body, because the thread is empty for now. We've got a thread ID, so just like before, let's save it for later. Cool. Now my user has finished typing, and I want to add their message to the thread. So let's do that. You can see here, I'm posting to the threads thread ID messages endpoint, and I'm passing in the data about the message. So the role is from the user, because the user's typed out this message, and the content is their question. So they're curious, and they want to know what the capital of France is. Cool. So now you can see we've got a response back, we've got a message ID, and the message has been added to the thread. Now you're probably wondering, how can I get my assistant to start acting on this thread? So we've introduced a new primitive called a run, which is how we've packaged up one invocation of your assistant. So let's kick off a run now and get my assistant going. You can see here, I'm posting to the threads thread ID runs endpoint, and I'm passing in the assistant ID. This is pretty cool. You can actually have multiple different assistants work on the same thread. But for now, let's use my geography assistant. I'm going to kick off the thread and tell you a little bit about what's happening in the background. You can see I've got a run ID, and the run is queued. So a run is how we've packaged up all of the work of loading your model, all the messages in the thread, truncating them to fit the model's context window, calling the model, and then saving any resulting messages back to the thread. So let's see what happened. We can fetch the messages on the thread to see how the assistant has replied. So I'm going to issue a GET request to the threads thread ID messages endpoint to see what there is. You can see we have the first message from our user, and then the assistant has replied saying the capital of France is Paris. So this is a super simple example, but we can talk about why this is better than the previous API. With the new Assistants API, I don't have to store any messages in my own database. OpenAI handles truncating messages to fit the context window for me. The model output is generated even if I'm disconnected from the API. And finally, I can always get the messages that the model output later. They're always saved to the thread. I think that's pretty cool. Great. So these are the basics of the API, and now let's move to what I'm most excited about, which is how it can power your application with tools. One of the most useful parts of Assistants is their ability to leverage tools to perform actions autonomously. Code Interpreter is a tool that is hosted and executed by OpenAI. When I enable Code Interpreter in my assistant, I can expand its capabilities to include accurate math, processing files, data analysis, and even generating images. To optimize the quality and performance of these hosted tools, we've fine-tuned our models to best determine when to call these tools, what inputs are most effective, and how best to integrate the outputs into the assistant's response. So now, let's get started by using Code Interpreter. So I'm actually building a personal finance app that I want to ship to my users to let them analyze their transactions. And we've already been in the terminal, so let's move over to the OpenAI playground. Here, you can see the playground that you know and love. It's super useful for testing chat completions, but we've actually refreshed it, and you can see there's a drop-down in the top left to pick the Assistants tab. Here in the playground, you can see you can create assistants, change their instructions, and you can start threads. Super useful for testing. You can actually see the assistant I just created in the API. All of that information is loaded here as well. So now, let's create a new assistant to show off the power of Code Interpreter. So I'm creating a personal finance assistant, so let's give it a name. I'm going to call it the Personal Finance Genius. And I'm going to tell it, you help users with their personal finance questions. Now, I'm going to select a model, and I'm going to select the newest GPT-4 Turbo. There it is. And I'm going to flip on Code Interpreter. With just one click or one line of code, you can enable Code Interpreter for your assistant. So let's save that. Great. So now a user has come to my application, and they want to analyze a spreadsheet of their transactions. Let's take a look at what it looks like. You can see there's a bunch of info in here, a bunch of numbers. The dates aren't even sorted. It's pretty messy. Let's upload that to the thread. And now my user is asking for a chart. So generate a chart showing which day of the week I spend the most money. Awesome. So now I've done a compound action to create a thread, add a message, and kick off the run. You can see things are happening in the background. Let's talk about what's going on. When we've kicked off the run, we will get all of the messages on the thread, summarize them for the model to fit the context window, determine if it's called any tools, execute the tools, and then give that information back to the model. So let's take a look. Oh, here we go. We've got the output, actually. It's actually pretty surprising. I did not think I'd be spending the most money on Sunday. But let's look at how we got here. You can see that our personal finance genius has started by telling us what's going on. It's actually written some code. We can click into the code here. And then it kept writing some more messages, and finally generated a chart, which we were able to see. So we can actually look a little more deeply to see how this happened. We can look at what we've called steps. Steps are basically the logs for your run, and they're super useful so you can render your own rich UIs to show your users what's happening. You can see the logs tab here. I can open it, scroll down, and find the steps for this run. This is reverse cron, so I'm scrolling to the bottom, and I can show you how we got here. So first, you can see we've created a step, and it has type message. So that corresponds with this first message we've created. Next, you can see there's a run step that is a tool call, and it's for Code Interpreter. So this is how the playground was able to render this snippet. The inputs and the outputs are directly in the API. Next, you can see another message creation step corresponding to this message, and then there's a few more Code Interpreter and message snippets. So all of this information is sufficient for you to render the same UI. The playground is actually built entirely off of our public APIs, so you can do the same. And speaking of, this is exactly what ChatGPT does under the hood when they're using Code Interpreter. So you can skin your application to look however you like. Great. Now let's move on to retrieval. The retrieval tool is incredibly useful when you want to expand the knowledge of your assistant. Maybe you have some information about your app or business that you want to imbue your assistant with. Rather than having to implement custom retrieval system on your end, OpenAI has built a tool that you can use with one line of code or one click in the playground. The retrieval tool does all of the document parsing, chunking, generates embeddings, determines when to use them, so you don't have to. Let's get started. So I'm going to hide the logs, clear this thread, and create a new assistant. So now I'm actually building an assistant to help my users use the OpenAI API better. So I'm going to create the OpenAI API wizard. That looks pretty good. Now I'm going to tell it that it's a helpful assistant, and then use the attached docs to answer questions about the OpenAI API. So I'm actually going to upload. I have a full dump of the OpenAI docs, just a markdown file, didn't process at all. I'm going to attach it to the assistant, and I'm going to flip retrieval on, just one click. Finally, let's pick the new GPT-4 Turbo model and save our assistant. So while this is being saved, we're actually doing the work on the back end to make this data accessible to the assistant. So let's see what it looks like when my user asks a question about the OpenAI API. So my user is curious, and they're wondering, how do I use the embeddings API? And so now we've kicked off a run. Again, what's happening in the background here is we're fetching all of the messages, truncating them however needed, calling the model, determining if the model has called the retrieval tool, executing retrieval for you, and then giving that back to the model to summarize. You can see here, we've actually grabbed a snippet from the docs, and we even have a citation, giving a direct quote from our docs so we can render that for the user. I think that's pretty cool. Just like last time, we can take a look at the steps and see how we got here. This one's a little simpler. We've got first the tool call to the retrieval tool, so you can let your user know that's happening while it's going. And then we have a step for message creation, so you can render this UI. Awesome. So now back to Olivier to explain how you can use the retrieval tool with different levels of file scope.
Thank you, Michel. Knowledge retrieval is extremely useful to augment the knowledge of your assistant with data from outside of the models. Concretely, retrieval can work in two different ways. Number one, you can upload and pass files at the assistant level. That's useful if you want your assistant to leverage that knowledge in every single interaction, in every single thread. So for instance, in Michel's example, on the customer support and the API docs, you should likely pass that information at the assistant level. The second option is to pass files at the thread level. That's useful if you only want that specific thread to be aware of that content. So if I'm uploading my personal bank statements, I should likely do it at the thread level. Behind the scenes, retrieval takes care of embeddings. Sometimes it even do not do vector search, and instead stuff the context. So you don't have to essentially handle that logic on your end. And we're excited to launch several new features over the coming month. For instance, we want to allow you to pick between different retrieval strategies to find the right balance between cost, accuracy, and latency. One final reminder, OpenAI never trains on any files or data that you pass to the API. And so that's the same for retrieval files. All right, let's move on to the last category of tools, function calling. So again, function calling are custom functions that you define to the models, and the model selects those functions on your behalf. We are excited to release two new features to function calling starting today. The first one is JSON mode. With JSON mode, the model will always return valid JSON. Behind the scenes, we made model improvements and improvements to our internal inference stack in order to constrain the sampling of the model and to make sure that every time the output complies with JSON syntax. So that's pretty useful. That means that you can trust that the model generates JSON that you can directly execute on your end. That's pretty cool. And by the way, JSON mode will also work outside of function calling. So if you use, for instance, the chat completions API, and you have a very simple application that just takes in data, extracts some fields, convert it to JSON, JSON mode will work as well. The second improvement to function calling is parallel function calling. With parallel function calling, the model can call multiple functions at a time. We've seen in many applications users giving multiple instructions at once to an assistant. So let's say, for instance, I'm building a car voice assistant, and I tell the assistant, raise the windows and turn on the radio. Before parallel function calling, that meant that you had to do two different model calls to OpenAI, which of course resulted in extra latency and cost. With parallel function calling, such a use case can be handled with one single call, which is pretty awesome. All right, let's do a demo now of function calling.
Awesome. Back to the demos. So I'm building off Olivier's example, and I'm building a new type of car. And I want a voice-activated assistant to be able to use some of the features of the car. So I have a bunch of functions that I've implemented, so let's pull up an assistant I've previously created. Here it is. So I previously created this car assistant, and I've told it it's a helpful in-car assistant and to please call the appropriate function based on the user's request. So with function calling, I have an assistant with all of my functions, and my assistant will tell me when to call my functions based on the user's input and what the most appropriate arguments are. This is super helpful, so I can figure out how to use my system to answer the user request. So let's take a look at some of the functions I have here. So I have a lot of the stuff you might expect to see. So honk horn, start phone call, send text message. So let's try it out. There's a user in my car, and they just said, that guy just cut me off. Let's see which function the assistant determines makes the most sense to call. There it is. Our assistants decided to honk the horn to let that guy know it wasn't cool. You can see here that we've called the honk horn function with no arguments, and so now I know how to pass it to my system. We also have a way for you to give the function output back to the assistant so it can keep going. So here, I'm going to enter the output. It was successful. Oops, I have a typo there, but that's all right. We're going to keep going. And the assistant says, I've honked the horn for you. Please stay calm. So actually, I'm realizing that there's a function here that's missing that I want to add. So let's show you the add function flow. You can see there's a button here where I can add a function. We have some helpful presets to get you started. So let's use the get stock app and change it a little bit to be my function. So I actually want a function to be able to change the volume in the car. So I'm going to call it set audio volume. And I'm going to give the description to the assistant. So set the car's audio volume. Now we need to tell the assistant how to call this function. So we can tell it about the parameters and whether or not they're required. So the main parameter for my function is the volume. And actually, the volume isn't a string, it's a number. And so this is the volume to set, and it's 0 to 100. Finally, we'll tell the assistant that this is required when you're calling this function. Great, this function looks good, so let's save it. And now I can save my assistant. You can see here the new set audio volume function is listed on the left. Let's start a new thread, and now my user is asking for a different query. They're saying, play Wonderwall and crank it up. In the background, my assistant is determining which of these functions makes the most sense to call. You can see here we've got the output, and there's actually two functions. This is showing you the power of parallel function calling. The first function starts the music with the query Wonderwall, makes sense, and the second sets the audio volume to 100, pretty cranked up. Now I can execute these in parallel and then get back to the assistant. Awesome, we're super excited about parallel function calling, and let's recap everything we've launched today. We're super excited to see what you build with the new Assistants API. We've added 3 new stateful primitives: the assistant for storing instructions, models, and tools, threads for keeping track of all your conversations, and messages, which are between the user and the assistant. We've also added the runs primitive for every time you want to invoke an assistant, and we've added steps, which are useful logs for rendering your UI based on what the assistant is doing. Finally, we've launched 2 new tools: code interpreter, retrieval, and we've made 2 huge improvements to function calling, JSON mode, and parallel functions. We're super excited to see what you build. And now over to Olivier to tell you about what's next.
Thank you, Michelle. So that was a lot, but there is a lot more coming soon. We plan to ship many new improvements to the Assistants API in the coming month. Number 1, we want to make the API multimodal by default. It should be able to accept and generate images and audio file. Number 2, we want to allow you to be able to bring your own code execution, so you can execute on your end the code that was generated by the assistant. A third big feature that we want to ship soon is to ship asynchronous support with WebSockets and webhooks to make it easier for real-time applications to use the API. It's a new feature, it's a new product, it's in beta. We would love to hear what you will build. If you have any feature requests, any wish lists, please tweet at us at OpenAI and show us what you build. We would love to hear all about it. Thank you so much, and enjoy Dev Day.
Thank you.